Hey, good morning, guys. I'm going to give this a try today and see if I can get this to work. Figure out how to screen capture, and I'm going to try and write on the screen. I got a little tablet thing. Hopefully these will be a little better. I do have a laptop that I borrowed from Rob that has a touch screen on it, but I don't have Rob's password. So as you can see, I don't know if you can see from your screen, but it is 5:30 in the morning, so I don't think Rob is awake yet. So I was going to go through a few of these. I'm not going to go through all of them because we did quite a few of them in class. So I'm going to pick and choose a few of them. If you guys have forgotten how to graph lines in general, you can send that in as a question, and I will make a video specifically about that. So I'll go over it briefly here, but if you have really specific questions about how to graph lines, I guess just send them to me, and I'll do my best to answer them. Okay. So. Little pencil on. Here. Again, remember, this number right here is our y-intercept, and this number right here is our slope. Okay? So the fastest way to graph a line is to start from your y-intercept. So my y-intercept is at 3. Okay? And that's a 0.03. That's a 0.03 that makes this true. In other words, if I plug in 0 for x, I will get out 3 for y. So negative 5/3 times 0 is 0, plus 3 is 3. So 0.3 is a point on my graph. Again, my slope is negative 5/3, which means I'm going down 1, 2, 3, 4, 5, and to the right 1, 2, 3. Don't forget that if it has a negative slope, it should be going down. The top number tells you your rise, the bottom number tells you your run. So in this case, it's down 5 to the right 3. Those are the only 2 points, but if you want to, you could keep going down another 5 over another 3, and then we're going to connect the dots. All right. Now, my other one here, again, we're going to start at negative 3 this time. Okay, and this is a rise of 1 and a run of 3. This time it's positive. Remember, if there's no sign, it's positive. So we're going up 1 over 1, 2, 3. If you want to, you can actually continue this pattern. You can go down 1, back 1, 2, 3. If you guys are doing this on a piece of paper, do as many as you can. Break out a ruler and connect the dots. So what do we got here? And we're going to connect these dots. Okay, what does this graph tell us? Now, this graph tells us all the solutions to this one, including all these fractions in between. But say, for example, 3, negative 2. In other words, if I plug in 3 here, I will get out negative 2 for y. Same thing with this one. If I plug in negative 3, negative 4, if I plug in negative 3 for x, I will get out negative 4 for y. The one thing they both have in common is this point right here, 3, negative 2. And that's going to be our solution. So 3, hey, why isn't it right? There we go. So 3, negative 2 is our solution. And I'm not going to do this for all of them, but just to show you, if I plug in 3 for x in the first equation, oops, eraser. Plug in 3 for x here. Well, negative 5/3 times 3 is just going to be negative 5. And negative 5 plus 3 is negative 2. And for my second equation, if I do the same thing, if I plug in y is equal to 1/3 times 3 minus 3, well, 1/3 of 3 is 1. And 1 minus 3 is negative 2. Okay, and so this point right here, this is your answer because it is the only point that these two lines have in common. Good? So that's your answer. Again, you should express your answer as a coordinate. So again, our big unit that we're talking about is systems of equations. And so we have a system here. We have two equations. We have two variables, x and y, and we just solve for both of them. Okay. I'm going to choose, should I do the next one? I'm going to skip down to number 5. Okay, I want to do number 5, and I think we're going to go number 4 and then number 6. My cat just jumped on my lap, so I have to move. Excuse me, Kit Kat. Sorry about that. All right. All right, so let's do this one again. Where are we starting from? We're starting from -4, and we have a slope of 3. Remember, 3 as a fraction is 3 over 1. Okay, so again, 3 over 1. So whenever you get an integer number here, whole number, well, not a whole number, but if you get an integer here, just throw it over 1. So what does that mean? From that point, we're going up 1, 2, 3 over 1, up 1, 2, 3 over 1, and up 1, 2, 3 over 1. So those are some integer solutions that make this true. We're going to connect the dots. Let me draw a line. I want to draw a line. Come on. There it is. Okay, so there's a bunch of points to make this one true. Okay, and in my second one, where are we starting from? We're starting from positive 3, and again, -1/2 means down 1 over 2. That's going to be our answer. Down 1 over 2. We can again continue this pattern and also go up 1, back 2, and up 1, back 2. Okay, connect the dots. Good. So again, what's our answer here is going to be this point right here where they intersect. And so make sure you actually write your answer on your paper. I've seen enough students do all the work and not write the answer on the paper. So the answer is 2. Let's write that again. It'll come out a little bit better. 2, 2. Good. So in other words, if I plug 2 into this one, 3 times 2 is 6. 6 minus 4 is 2. -1/2 times 2 is -1, plus 3 is 2. So that's going to be our solution right there. I do just want to go over this one real quick. This one, people freak out when they see these. These are actually easier than what you think because they actually gave you part of your answer. When you will write your answer, part of your answer will be -1. So that's -1. So why is it keep doing this? Okay, so part of your answer will be -1. Y is equal to -1. Okay. So again, one of the other methods we talked about was substitution. If you were to substitute -1 into this equation, you could subtract 4 and then do the reciprocal here and solve for x that way. The big problem that a lot of people have is, what does this line look like? And it's counterintuitive because the y-axis goes this way, but actually y equals lines go from left to right like this. So this is the line, y is equal to -1 right there. Okay, and why? Because every single point on that line has y equal to -1. This is -5, -1, -4, -1, -3, -1, -2, -1, -1, -1, 0, -1, 1, -1, so on and so forth. So all of these points have one thing in common, and is that their y value is equal to -1. Okay. This other one, we're going to graph as usual. We're going to start at 4. Okay, and our slope is -5, 2. So a -5 halves rather. So we're going to go down 1, 2, 3, 4, 5, 1, 2. And again, if we could go 1, 2, 3, 4, 5. The next point would be probably here somewhere. Okay, just as a reference point. So if we connect those dots. There you go. And what's our answer? Our answer is going to be, how do I do this over here? 2, right? 2, -1. Okay? So again, what's our answer? 2, -1. The last one I will want to go over is number 6. And the reason we'll go over number 6 is that this is going to be a unique case. These lines are going to be parallel. This is actually a unique case because there are not going to be any solutions. There's not going to be any intersections. This will be a big thing when you guys get in high school, when you guys take geometry in the 10th grade, hopefully, that two lines are parallel when they have the same slope. And again, what we can think of is this is going to start at 2 and then go down 2 over 1, down 2 over 1, down 2 over 1. This was going to start at -2 and go down 2 over 1, down 2 over 1. And essentially they're never going to catch each other. So let's graph that out. So we're going to start at 2. And this is -2 over 1, so down 2 over 1, down 2 over 1, down 2 over 1. And again, if we wanted to, we can continue the pattern up to back 1. Connect the dots. And this one's going to start at -2. Again, so it's also going to go down 2 over 1. So again, if you kind of think about it, it's almost like they're chasing each other and they're never going to intersect. Okay. So if we connect these dots right here, no, that's attached video. Okay. We connect these dots over here. Again, I'm going to try and line these up the best I can. Just kind of see where they will go. And what do we got? We have two lines that, again, are parallel. So this has no solutions. There is nothing that these have in common that makes them true. So again, if this just has, if you want to get real fancy about it, no real solutions. That were real for you guys doesn't mean anything, but so if you just wrote no solutions, that's fine too, but you really should be writing no real solutions. Again, they will never intersect. If we just kept following that pattern on and on and on, they'd never intersect. Just to show you guys what that looks like, because I know we've gone over some of the other stuff. If we were to, hold on, sorry. If we were to set them equal to each other, again, -2x plus 2 and -2x minus 2, when I add 2x to both sides, I'm going to get -2 is equal to +2, which is impossible. Anyway, I will try to make you guys a video every day. I will go through that other sheet tomorrow morning. But just so you guys know, the answers to these are at the end. So you can double check. We got no solutions. We got 2, -1. We got 2, 2. So you go down and take a look at the answers. Try and do them. If you have any problems or anything, any specific problems that you guys want to go over, I will gladly do them. This should be mostly a review. We did a bunch of these in class. There was another sheet there as well. It's guided notes. I want you guys to work on the vocabulary as well. So yeah, the sooner the better. And like I said, if you guys have questions, send them over, and I'm happy you guys are taking the time to look at this. So thank you so much. See you guys later.